number of transfer units. So NTU is nothing but number of transfer units and effectiveness. So what is meant by effectiveness? So NTU analysis, when we have to use NTU analysis and when we have to use LMTD analysis. LMTD analysis is used when inlet and outlet conditions are given. So a heat exchanger can be designed by the LMTD when inlet and outlet conditions are specified. However, when the problem is to determine the inlet or exit temperature for a particular heat exchanger, the analysis is performed more easily by using a method based on effectiveness of the heat exchanger and number of transfer units. So what is meant by effectiveness? So it is defined as the ratio of actual heat transfer to maximum heat transfer. Actual heat transfer to the maximum heat transfer. So how to calculate that actual heat transfer rate? So Q is equal to mCp delta T. So what is the equation related to hot fluid? That is m dot H into Cph into Th1 minus Th2. M dot H is nothing but mass flow rate of the hot fluid. Cph is nothing but specific heat of the hot fluid. Th1 is nothing but inlet temperature of hot fluid, and Th2 is nothing but outlet temperature of the hot fluid. So by using that equation, you have to calculate the actual heat transfer rate. So for the cold fluid, how to calculate the actual heat transfer rate? That is m dot C into Cpc into bracket Tc2 minus Tc1. So m dot C is nothing but mass flow rate of the cold fluid. Cpc is nothing but specific heat of cold fluid. Tc2 is nothing but outlet temperature of cold fluid, and Tc1 is nothing but inlet temperature of cold fluid. So by using these two equations, we have to calculate the actual heat transfer rate. So now we have to calculate the maximum heat transfer. So when there is a maximum heat transfer, so if the temperature difference is maximum, so how to calculate when the temperature difference is maximum? So there are four temperature: inlet temperature of hot fluid, inlet temperature of cold fluid, outlet temperature of hot fluid, and outlet temperature of cold fluid. So from that, which temperature is maximum? That is Th1, that is inlet temperature of hot fluid, and which temperature is minimum? That is inlet temperature of cold fluid. So this temperature difference is maximum, and we have to multiply by that equation by minimum specific heat. For that we get the maximum heat transfer rate. So what is the value of maximum heat transfer? Q max is equal to C minimum into bracket, C minimum is nothing but heat capacity, minimum heat capacity into bracket Th1 minus Tc1, Th1 minus Tc1. So by using that equation, we have to find out the maximum heat transfer, and ratio of this actual and maximum heat transfer rate is nothing but effectiveness. So what is meant by C, capital CH and capital CC? So capital CH is nothing but hot fluid capacity. So how to find out that hot fluid capacity? It is product of mass flow rate and specific heat of that hot fluid. So mass flow rate is m dot H and specific heat is Cph. Similarly, what is this Cc? Cc is nothing but cold fluid capacity. So how to find out that cold fluid capacity? That is m dot C into Cpc. So there are two values of heat capacity, that is Ch and Cc. So from that value, you have to compare and find out the C max and C minimum. When the maximum value of Ch is there, that Ch is nothing but C max, and if the value of Cc is minimum, then Cc is nothing but C minimum. So in this way, we have to calculate the heat capacity. So that is nothing but effectiveness. So thank you.